Now, question 32 is a volume question, right? So, like we were saying, we're looking at this shape here, and they gave us the dimensions of it. They say this is representing an aquarium, and we need to calculate the volume of the aquarium. So, in a question like this, first thing that we need to look at is what shape is it that we're dealing with. And if we look carefully at this shape, which we know it's supposed to represent something three-dimensional, so a three-dimensional shape that consists of rectangular faces. What solid do you know consists of rectangular faces only? Do you know any solid that contains rectangular faces? All the faces are rectangular faces. So if you can recognize that this solid is a cuboid, right, you'll be able to identify the formula for the volume from there, right? So we're dealing with a cuboid, and to get the volume of a cuboid, we're going to pay attention to the dimensions of the cuboid. The dimensions being its length, its width, and its height, right? So length by width by height, this is how we calculate volume of a cuboid. And remember, like I was saying, it's a three-dimensional shape, it's a solid, right? So that's why we have to have three dimensions basically when we're calculating the volume here. And the three dimensions would be the length, and in this case the length is 60 centimeters, right? This is the long side here. The width of the cuboid would be this distance from front to the back, right? So this is 50 centimeters, and the height of our cuboid is the 40 centimeters. So we're going to take these three measurements here, and we're going to multiply them, and we'll be able to get the volume of the cuboid. So the volume of the cuboid is calculated by multiplying 60 by 50 by 40. Now all these numbers are multiples of 10. So we can do a little computational shortcut here, where since all of them end in zeros, multiply the first digits of all three of them. So we're going to multiply 6 by 5, and then we'll multiply that product by 4. So 6 by 5 is 30, and 30 by 4 is 120. So we'll write that down, right? So from here now, we just have to pay attention to the number of zeros in our product. So I have three numbers which all end in zeros. So I'm going to add 3 zeros at the end of my product of 120, right? So now let's add on those 3 zeros. And remember, like I said, this is a computational shortcut. So that way it eases you up on having to do all that long multiplication, and you'll take a long. Multiply the first three, the digits of the first of these three numbers, multiply 65 by 4, and then after that, because we have three numbers all ending in zeros, we just add 3 zeros at the end. So this is the volume of the cuboid, and remember, units are important. So we just need to write in this on the answer line here, but if you're writing a statement for your working, the volume is 120,000 cubic centimeters, right? 120,000 cubic centimeters, that's volume. So we know we're dealing with volume, so the unit is now centimeters cubed, because our units of measurement for the dimensions of the cuboid were given to us in centimeters. So 120,000 cubic centimeters is your volume. Now, that sounds pretty large, right? Sounds like a lot. So the next part of the question, they're asking us how many liters of water will the aquarium hold when it is half filled. So we have to pay attention to the bits of information that they put in there, right? The first thing is they're asking us for how many liters of water. So when we think about this now, liters basically is another unit of measurement of volume, but this time we're dealing with the measurement of volume of fluid, right? We use liters for fluid, so that's why when you're looking at beverage cans and containers in general, whether it's a box or a bottle or a can, you will notice that they give you the volume in ounces sometimes, or depending on the size, they would give you in liters, right? So this part of the question now is asking us to basically take our volume and convert it into liters. But it's not just asking us to take the 120,000 and just convert it into liters. It's actually telling us that we want to know what the volume of the aquarium is when it is half filled, right? So that's another key thing to pay attention to. We want the volume of the aquarium, yes, in liters, but we want for half of the entire aquarium, right? For us to convert from the volume in cm cubed first of all to liters, we need to have a conversion rate. So even if we don't know the conversion from centimeters cubed to liters, they actually give that to us right here, right? They tell us that for every 1,000 cubic centimeters, that's a liter. All right, so in here now we have all the information, we understand what they're asking us to do. Let's start working on this problem. And the first thing that we have to figure out is how we're going to approach this question. Now, we could do this one of two ways. One, we could convert our volume from cm cubed straight to liters and then just find half of that, which might sound very simple and easy. Or we could find half of the volume in cm cubed and then convert that to liters, right? Both approaches will still get us to the correct answer, right? But it's really and truly up to you, whichever way you feel more comfortable. So let's do converting the volume to liters first and then find just half of that. So if I have to convert my volume from cm cubed into liters, I have to use my conversion rate. So let's write down what our conversion rate is, right? Our conversion rate is 1,000 cm cubed. 1,000 cm cubed is equal to 1 liter. So what I'll do now, I'm going to divide my volume in cm cubed by 1,000. And when I do that, I'll be able to convert my volume into liters, right? So we're going to divide 120,000 by 1,000, and we'll get liters from this, right? And it's as easy as this. All we have to do is cross off zeros because the 120,000 and the 1,000 both have common multiples of 10, 100, and even 1,000, right? So let's cancel off the zeros. And when we cancel off the zeros, we will remain with just 12. And then after that, all we have to do is find half of this and we'll get our answer, right? So the volume when the container is half filled, it will be a half of 12, right? So the volume of the container when it is half filled, that volume is a half of 12, which is 6 liters, right? Because a half of 12 is 2 into 2, 1, 2 into 12, 6. And that's how we get our volume.